In this video, we will add another differentiation rule to our toolbox. This is useful when you have two functions divided. So the quotient of two functions, f of x over gx. If both of them are differentiable and you're trying to find their derivatives, what will happen is, well, first thing, the derivative of quotient is not the quotient of derivatives. That's the first thing. Don't do that. The second thing is that what is the right rule? The rule is this: derivative of the numerator times the denominator minus the numerator itself times the derivative of the denominator over the denominator squared. This is called the quotient rule. And well, it has the rule has some similarities to the product rule. In the numerator, what you see is almost the product rule f times g. This with one difference. Instead of a sum, you get minus. There are good reasons why you see it here. And in the denominator, you have just the function, the denominator squared. No derivatives in the denominator. Okay, so let's just go do some examples. Here, let me bring the examples I have prepared for you. Okay, so I have functions, I have to differentiate, find the derivative, and well, these functions are quotient of two functions. This is derivative of x squared plus 1 over x prime. So the quotient rule. It says find the derivative of the numerator times denominator minus numerator itself times the derivative of the denominator over the denominator squared. This gives us, well, this is already the quotient rule is done, but now I have to find the derivatives. Derivative of x squared is 2x. Derivative of 1 is 0 times x minus. Derivative of x is 1 over x squared. And well, that finishes everything for us. 2x times x, this is 2x squared minus x squared plus 1 over x squared. Let me erase the rest. Actually, we can do a little bit more simplification here. Get, well, actually, x squared plus 1 over x squared. It's interesting function here. Yeah. So how about this one? Well, f prime of x, this is quotient of two things. And we have the quotient rule. So 2x minus 1 prime. Derivative of the numerator times the denominator minus numerator itself times the derivative of the denominator. Then denominator squared. Now we find each one of the derivatives written above. Derivative of x plus 1 is derivative of x, which is 1, plus derivative of 1 is 0, times 2x minus 1 minus x plus 1 times derivative of 2x minus 1 is 2 minus 0 over 2x minus 1 squared. And now we have 2x minus 1 minus 2 times x and times 1, actually negative 2 times x. So it will be negative 2x minus 2. And then the denominator is 2x minus 1 squared. And that gives us what? This cancels with that. We get negative 3 over 2x minus 1 squared. And the last piece here. Oh, okay, so we are trying to find h of x prime. This is 1 over x squared minus 3x plus 1. Well, this is quotient of two functions. The numerator is 1. The denominator is x squared minus 3x. So then apply the quotient rule here. Derivative of numerator times the denominator minus the numerator itself times the derivative of the denominator over denominator squared. See, derivative of x1, the constant 1 is 0. So this piece will be times 0. So 0 times x squared minus 3x plus 1 minus 1 times x. So it is just x squared plus 3x. Oh, no, sorry. I have to find the derivative of that. I thought this is derivative. So 1 times derivative of x squared minus 3x is 2x minus 3 plus 1. The derivative of 1 is 0. And that gives us x squared minus 3x plus 1. Well, the first part just goes away, 0 times that. Then the numerator will be minus 1 times 2x minus 1 times negative 3. So it is negative 2x plus 3 over x squared minus 3x plus 1 squared. And that is the derivative of that function there. Let's do two more examples. In these examples, we are trying to find not the derivative, well, the value of the derivative at a point. It means that we have to first find the derivative and then plug in 1 for x. So let us find f prime of x. This is 3x plus 2 over x to the power 6 plus 5x to the find the derivative. And that would give you derivative of numerator times the denominator minus numerator times the derivative of the denominator and then denominator squared. This now we can differentiate. Derivative of 3x plus 2 is just 3 plus 0 times x6 plus 5x minus 3x plus 2 times derivative of x to the power 6 is 6x to the power 1 less plus derivative of 5x is just 5. And let me get a little bit more space here. And then what we have, this is x6 plus 5x squared in the denominator. We don't change that. Okay. So we have everything now ready. 3 times x6 plus 5x minus 3x plus 2 times 6x5 plus 5 over x6 plus 5x squared. Now f prime at 1 is 3 times 1 to the power 6 plus 5 times 1 minus 3 times 1 plus 2 times 6 to the power 6 times 1 to the power 5 plus 5. 1 to the power 6 plus 5 times 1 squared. So the value of the derivative at 1 is going to be 3 times 6, 18 minus. This is 5 times 11. It's 55. And the denominator is 6 to the power 2, which is 36. Well, that gives us what? 37 over 36? Minus 37 over 36, yes. Okay. How about this one? Well, all these things, again, all of them, you have to differentiate first. And while you're differentiating, the product rule, derivative of numerator times the denominator minus numerator itself times the derivative of the denominator over the denominator squared. And that gives me derivative of 2 squared plus 1 is 2t plus 0 times 3t plus 2 minus t squared plus 1 times derivative of the denominator. Denominator is 3t plus 2. Derivative would be 3 over 3t plus 2 squared. And that gives us 2t times 3t plus 2 minus, well, there's a 3 there, so it will be this guy. I can simplify a little bit, but I will leave it like that, just because what we are interested in is derivative of the function at 0. It means that for all t's, you plug in 0. And over 3 times 0 plus 2 squared. This gives us what? This gives us, this is whole 0. This is negative 3 in the numerator. And this is 2 squared, which is, so the derivative of g at 0 is negative 3 over 4. Let's move to the other example. Find an equation for the tangent line to the graph of this function at 1. Remember, to write an equation for a line, we need the slope. For the tangent line, the slope is given by the derivative of function at that point. And we need a point, which in this case will be 1 and f at 1. So 1, if you plug in there, you get f at 1 is 1 squared plus 2 plus 3 over 1 plus 2, which is 6 over 3, which is 2. Well, that is 1, 2. We have a point, we have a slope. Well, we have to compute the slope. Then we go and find the point slope form, and then from there the standard one. Okay, so we need then find f prime of x. This is quotient, so we have to apply the quotient rule. Derivative of the numerator times the denominator minus the numerator itself times the derivative of the denominator, and then the denominator squared. This gives us what? This gives us 2x plus 2 plus 0, this is the derivative of numerator, times the denominator, minus derivative of the x plus 2 is just 1 plus 0, and we have it there. So that is what we were looking for. Now plug in 1 into x. So what we will get is 2 times 1 plus 2 times 1 plus 2 minus 1 squared plus 2 times 1 plus 3 times 1 over 1 plus 2 squared. And this gives us 4 times 3 minus 6 times 1. And this is 3 squared. This gives us 12 minus 6, 6 over 9, which is 2 over 3. We found m. We have the point. Then we write y minus y1 equals to m, x minus x1. This gives us y minus 2 equals to 2/3 times x minus 1. And from there we have 2/3 of x minus 2/3 plus 2, which simplifies to 2/3 of x plus, is it 4/3? Yes. That is the equation, an equation for the tangent line at that point. Okay. Well, here we have two functions which have, we don't have the whole functions. What we have is just some values. Okay, you may say, how can I going to differentiate this thing? Well, in this case, for example, we are trying to find h prime of x, which is, f of x over gx. You find the derivative of that. I don't know what is f and g, but we can write the quotient rule. And, set x equal to 0. When you set x equal to 0, this will give us f prime at 0 times g at 0 minus f at 0 times g prime at 0 over g at 0 squared. I should have started with the black one. Doesn't matter now. Let me make it black before it's okay. And when you get to this point, you see these are just values that you have to pick from the table. F prime at 0, so this is f prime at 0 is 2 times g prime, g at 0, it is negative 2, minus f at 0 is 1 times g prime at 0 is 3 over g at 0, again, it is negative 2, but square of that. So what we found is h prime at 0 is negative 4 minus 3 over 4, which is negative 7 over 4. We didn't know what are the functions. We only knew the rules, and we applied the rules for those ones, and then we used them to find the value of the derivative. How about this other one? Here, h prime of x, we may need to apply more than one rule here, but we will start just one by one, going to see what is happening. Prime. Okay. This says what? We have two functions divided, so I have to apply the quotient rule. Derivative of the numerator times the denominator minus the numerator itself times the derivative of the denominator. Then denominator squared. While trying to do the differentiation of these numerator and denominator, you have to apply the other rules. For example, here, you see for this one, 3 times f you want to differentiate, so it will be 3f prime of x. We called it constant multiple rule. Times gx plus fx minus 3 times fx. We are trying to find derivative of f plus g. This is sum rule. So this will be sum of the derivative of f and g, and then we have the denominator square. Now set x to be 1. It means that we have 3f prime at 1 times g at 1 plus f at 1 minus 3f at 1 times g prime at 1 plus f prime at 1 over g1 plus f at 1 squared. So this is what is going to be h prime at 1. Now we plug in one by one the number. 3 times f prime at 1 is 0 So I don't need to compute the other ones, but let's just do g at 1 is 1 plus f at 1 is 2. So that piece is going to be 0. I didn't need to compute, but I just trying to plug in every values you have there. F at 1 is 2 times g prime at 1 is 3. This is the value. Plus f prime at 1 is 0 over g at 1 is 1. F at 1 is 2 square. Now what we found, the first piece is 0 minus 6 times 3 over 3 squared. That is what we have. And this gives us minus 18 over 9, which is negative 2. So you have to be able to apply the quotient rule in different situations. You may need to do a little bit more practice, but basically you have all the facts you needed in this video and very good examples of the quotient.